That we are going to do today would actually require some basic understanding of the terms which are related to it. So when I say term, I would mean uh, eigenvalues. Then I would also mean what is factor analysis as such. I would also be meaning what is rotation, and why do we require rotation, the kind of rotations and all. So very quickly to go through what we did last time, rotation actually first of all let's talk of eigenvalues. Eigenvalue is something that talks of variance that is explained by a variable. Rotation is something that rotate the factors when factors do not, or when the statements or items actually do not load onto the respective factors very clearly. So we have to actually see, or we have to obviously see that which statement is going into which factor, and for that we require rotation. So that is something that we are talking of now. So starting straight away, we will be discussing factor analysis, right? So let's consider this example. This is an spss file which has some data into it, and this data actually is of a standard scale that has been adopted worldwide to measure service quality. So service quality, this scale is also known as SERVQUAL, SERVQUAL. This is basically short form of serve means service, qual means quality. So service quality. So this scales measure service quality. So what does it say, or literature talks about service quality, is that there are two things. One is what you expect out of any service, and second is what you actually get when you are actually receiving that service. So if there is any gap between these two, then you say that there is gap in service quality and the quality of service is not good. So Persuroman was the literaturist who actually has come across with this scale which was known as circle. So he gave us 22 items or 22 statements, and he says that if you can get responses of respondents onto these 22 items, then these will actually help us in measuring the service quality, right? So this spss file that we are looking at here is actually a data of those 22 items that we have just very briefly discussed. So these are 22 items that we are talking about, right? So first item would mean uh, our hospital is having latest equipment. So when we say our hospital is having latest equipment, it would mean that this quality of service has been tested in hospitals here. All right. So we are talking of hospital service quality being tested using this scale of service quality. So now what will we do, as we have discussed last time, that factor analysis is a data reduction technique, and we tend to reduce the data and have some dimensions out of it rather than going and analyze all the 22 statements separately. So what we would try to do here is, instead of me as an analyst going through all these 22 statements and analyze them one by one, I would rather have a smaller number of statements, and I would say that I will only analyze those statements. And hence, essentially what I am trying to do is I will be trying to reduce the data that I have to analyze. So whenever I have to do that, I will eventually go for factor analysis. All right. Uh, Whatever scale that you come across, here we are talking of service quality, you will find that factor analysis is a technique which is applied in 95 out of 100 scale works that are being done. So when I say scale works, it means the primary data that is collected on a standard scale. So whenever you have multi items, then people tend to have smaller number of items which explain maximum possible of the variance, and then they go ahead with these things rather than going ahead with all the items that are part of the questionnaire. So, and hence, to do that, the only technique available with you is factor analysis. So eventually you will find factor analysis being applied in every second study. So here we will also try to reduce these statements into some lesser number of statements, or lesser number of dimensions rather, should I call it, or they technically are called as factors. So let us try to have some factors out of it. So when you have to apply factor analysis in spss, spss is statistical package for social sciences. So when you have to do that, you go to analyze. So if you would remember, when we were doing ANOVA or T, we have gone into compare means, right? And the reason of going into compare means when we were doing ANOVA and T was because it basically is a difference of mean test. So we would be checking the means of two groups. So we would be comparing those means, and that's why all these T and ANOVA are under the head of compare means test. Now we have to apply factor analysis. So you will not find anywhere written data analysis, written factor analysis. But you have to know that which technique you are going to apply. This is factor analysis, and what this technique is about. This is about data reduction. So here we will go into data reduction. So data reduction, you will find three techniques. Today we will be discussing factor analysis. All right. So you have to come to analyze in that data reduction, and in data reduction you will come across factor. All right. So I have clicked on to factor. So I'll come up with a window like this. So now what I have to do is, likewise, any of the statistical tests that I'm going to apply in SPSS, I have to drag certain statements into the analysis active window, or this window of variables, you can say. So I will drag this 22 items which I am talking of, this 22 questions of my scale into this variable window, because I want to apply factor analysis onto them, and I am under the head of factor analysis. So eventually what I have done, I have got these 22 statements into factor analysis, right? So this is what I will do. Now you are seeing some five tabs here. So first tab is of descriptive, second is of extraction, third is of rotation, fourth is of scores, and fifth is of options. So let us look at them one by one, and which parts of these tabs are important for us at this stage. So first of all, let us go to descriptives. So in descriptive, we will click on to initial solution that by default would always be clicked into SPSS. So here, nobody stops you to click each and everything, and you will have a bulky output file. But rather than going and clicking each and every tab of it, one would actually try to go for something which is most relevant to him. So before application of factor analysis, it is always said that we should check something which actually try to check the assumption which is attached with factor analysis, and that assumption is checked with these tests, which are KMO and Bartlett's test of specificity. So we will discuss what these tests are, and we will also discuss the genesis behind these tests being the ones which checks the assumptions of factor analysis. So what I have done is I have come into descriptives, and in descriptives I have clicked on initial solution that was always there. I have manually from my side I have clicked onto KM1 Bartlett's test of specificity. All right. So I will say continue. Right. So descriptive column is this. So extraction. Now this is an important thing. Now what happens is, when we say that these 22 statements would actually be confined into say 4 dimensions, 7 dimensions, 8 dimensions, or 2 dimensions, or 3 dimensions, but essentially we are talking of having lesser number of dimensions instead of having all these things. So when we subject them to factor analysis has some extraction methods into it. There are some methods which are followed mechanically or mathematically, which actually extracts the factors out of these statements. All right, and that is why these are called as this comes under the head of extraction. So factors are extracted, dimensions that we are talking of are extracted, right? So this is something which is called as extraction. So in extraction, when you will go into SPSS, you will find lot many methods of extracting factors out of the items. Extracting factors out of the item would mean 22 items we have subjected, and what essentially we are trying to do, we are trying to have a smaller number of dimensions which would represent all these 22 dimensions, so that we can take ahead these lesser number of dimensions ahead in analysis. All right. So what technically do we call it? We call it that these dimensions or these factors has been extracted out of these 22 items. This is how we do it. If you can look at this window, you will find this method thing here, and then you have a drop down menu, and when you will drop it down, you will find lot many here. All right. So these all kind of extraction methods can broadly be divided into two parts. If you can recall, when we were trying to do factor analysis, we have theoretically discussed that factor analysis is done for two major important things. One is that we do only to reduce the data. The main aim is to reduce the data with the maximum variance explained. So which means that only objective is to have lesser number of things to be analyzed further. So that is one objective of it. Second objective of factor analysis could also be to have hidden subliminal dimensions from this data. All right. Structure detection we can also call it. So second major thing of factor analysis would be to detect the structure which is latent, which is not visible from the surface level, and hence we would be trying to have these hidden dimensions by application of factor analysis. That is its main job. There are two types of data. Now, suppose if I ask anyone where is Delhi, or suppose I ask that Delhi is capital of India, and I give him five options: strongly agree, strongly disagree, agree, disagree, and neutral. Chances are, because this is a factual information, everyone knows it, or it is a fact. So it there are chances that he would give us exact results. So these results are exact, right? But if I ask him that I like New Delhi, and then I give him five options: strongly agree, then neutral, then agree, and then disagree, or whatever. So now the answer which he gives is highly a perceived one. All right, and this is exactly what happens in behavioral studies. So in such cases, it is recommended that when we are trying to apply factor analysis on behavioral data, wherein we are trying to get dimensions out of the data, where we are trying to get the latent structure out of the data, then we should be going for the second type of factor analysis, which essentially is called as EFA, which is exploratory factor analysis. So exploratory factor analysis would mean it is exploring, right? It is exploring the factors out of these dimensions. And the other one, which is simply to reduce the data and have minimum number of things to you, then that thing is simply called as factor analysis. So the extraction method in the first part, wherein we are just trying to reduce the data, is principal component analysis, and that popularly is known as PCA, right? So that is PCA for you. All the other methods that you're looking here, unweighted least square, maximum likelihood, principal access factoring, alpha factoring methods, they are advanced and they are meant for structure detection, or they are meant for finding out the latent hidden dimensions out of the data. And in behavioral sciences, it is recommended that these extraction methods are applied instead of principal component. What principal component does, it just reduces the data with maximum amount of variance explained. What these other extraction method do, they actually talks of commonalities instead of maximum variance, and they talk of common factors. All right, because we are talking of behavioral things. So we will not be going into these things now, because they are meant for the advanced stage of factor analysis. So today we will try to do principal component analysis, which eventually is used by a lot many people even in behavioral sciences, which literature nowadays have started talking of as a wrong application of factor analysis. So when we say that factor analysis is the most used technique throughout the research world, then I would say that it is most misused techniques also, because when you are applying principal component analysis onto some data, right, which actually is not meant for it, or out of which you are trying to derive the latent hidden dimensions, then PCA would not be a thing that you should be doing. Rather, you should be doing the other methods of extraction, be it principal access factoring, be it alpha factoring, be it maximum likelihood method. So those should be applied, right? But now here our objective is to just understand the execution of factor analysis. Then let's go ahead with PCA. So here I have selected this extraction method of PCA, which is principal component analysis, right? So here we have also clicked on to correlation matrix, and that is by default in SPSS. So if you can remember, then we have also talked of rotation. So here in display section, it is checked that we should be having unrotated factor solution before us. Now this is an important thing, and we would look at it. So we have discussed about rotation a lot, and we have come to the conclusion that this rotation is basically not a compulsory thing that we should be doing in factor analysis, right? It is not a compulsory thing that should be doing with factor analysis. Now what? When I have clicked onto this thing, which is unrotated factor solution, now that would mean that I want to have unrotated factor solution. Now there is this scree plot also. Let's check it out also. What is this scree plot? Now when we were discussing about the number of factors that should be extracted out of a solution, there are many ways or many methods that we can talk of which will tell us how many factors to extract, right? So here scree plot is one of those ways which eventually would help us in determining the number of factors that we should be extracting out of this data. Then you are looking at extract thing, and under it you are having eigenvalues over 1. So we have at length discussed what are eigenvalues, and we have discussed an eigenvalue of 1 would mean what, an eigenvalue of 2 would mean what. So here in extraction condition you can also set a minimum condition that if I am accepting anything as to be a factor, then I would say that eigenvalue of that factor should be at least 1. It can be more than 1, but it has to be at least 1. Only then it would be accepted as a factor. And there are reasons for it. If you would look at eigenvalues thing, then we would eventually find that if this is a1, this is a statement, and then we have a2, an eigenvalue of 1 would mean that this a1 is actually explaining itself fully. Anything which is beyond 1 would mean that it actually is responsible for explanation of variance of other variables also, and hence this factor can be taken ahead. So we have kept, or by default in SPSS you would always find that eigenvalues condition is always kept at 1, but that is not the only condition. So the conditions, or the ways, I would rather call it, right, or the ways to select the number of factors, important to understand. Now let's talk of first way, setting eigen value equal to 1. So we would say that we would only accept a factor when eigenvalue is more than 1, right? So that becomes my first condition. Maybe that can be. Second thing is by studying scree plot. Another thing, we would be doing that because we have checked onto scree plot thing. Third is if you have literature back of number of factors that can be drawn out of items. So what does this statement means is, now suppose we are talking of circle here, right? We are going to apply factor analysis onto these 22 dimensions which are measuring service quality. Service quality or circle for that matter is a scale which has been accepted worldwide, and literature says that it basically has 5 dimensions, right? And these 5 dimensions are tangibility, reliability, responsiveness, assurance, and empathy, right? So these are 5 dimensions that across the globe has been found out and has been tested for reliability and validity. So now we know that whenever we are having this factor analysis thing being applied onto these 22 items of circle, then we know that there should be 5 factors, so there should be 5 dimensions, so there are 5 dimensions which should be eventually coming out of it. So you can straight away mark 5 as a number of factors when you're trying to do factor analysis. So if you can look at this thing here, then instead of setting eigenvalue equal to 1, you could always go on to number of factors and you could always say 5. So I want 5 factors because I know beforehand, literature have talked about it, literature has proved it multiple times that there are 5 factors or 5 dimensions from this data, right? But that is something that we should not do when actually we are trying to see that how does these statements is behaving in these conditions, these specific conditions. We should not forget that any scale which has been developed somewhere else, maybe say states, United States here we are talking about, the setting in which that scale was developed, the setting in which the scale was tested is actually different. from Indian counterpart. So in a country like India where language changes after 22 kilometers, what to talk of a scale which was developed in USA, and to say that it would actually and as it is be adopted here in India. So let us not just get accept, or let us not just accept the 5 dimensions which were found out in USA. Let's try to find out how many dimensions these items gives here in India, right? And that is something that is known as cross-cultural study. So we always talk of cross-cultural studies because in India you would see that the research contribution to the research community of the world is very poor. So what do we do? What do we intend to do is we just pick up the skills that are developed somewhere else and we just apply them here in India without even looking at the cross-cultural effect that it can have, right? Though circle is a thing which has also been applied in India and has found out 5 dimensions many of the times, but when this circle is for service quality, so services are many. So when you say hospitals, they are in service industry. So when you apply circle in hospitals, then that becomes measuring service quality of hospitals. When you apply circle in banking, then that becomes service quality in banking. When you apply circle in hotel industry, which is also service industry, then that becomes circle being applied in hotel industry. So across the industries also we should be testing it, and it has been fully tested. This example that we are talking today is actually applying circle in hospital, and this is a major study that was conducted out of a doctoral program of uh, someone, and he is doing it for entire country. So he have included all kind of hospitals, be it corporate hospital, be it a trust hospital, be it a private hospital, any kind of hospital. So now he's testing his service quality of hospitals. So though we know that there are 5 dimensions which has already been proven, so it would not be a wrong thing to just check on to say Eigen value as 1. And let's check it, how many dimensions do we get out of it? Who knows? So there we are here in extraction thing. In last you are saying something which is known as maximum iterations for convergence, and by default they are 25. Do you remember rotation thing? We have discussed rotation, and when we say that rotation, we were talking of something like this thing having these two axes. This suppose was F1, right, and this suppose was F2. Now here rotation we were talking of, this has been rotated in this dimension, and now F1 has become this. So this is something that we were talking of. So this is new F1, and now F2 has gone into this direction. So this shaded thing, this broken line in between actually represents F2. So when this actual rotation was done in order to fit this item in this factor, because earlier this was too far away from F1, now it is nearer to it and it can actually be directed to F1. So now when we are doing this rotation, now suppose it has been rotated from this point to this point. Now this is rotated once, right? This is one iteration, IT, that's what I am writing. All right. So suppose now by rotating this, the factor which was here, or the item which was here first, was just this much away from F2 previously. Now it is equidistant from these two also. Now this has problems. Now we also have to get this into account, and we will rotate it once more. So these are called as iterations, right? So here we are with iterations, and maximum iterations by default in SPSS are 25. So we set, which means we will allow this factor solution to be rotated these many times so that a viable solution can be reached onto, if at all you are talking of rotation. So let's click to continue now. Right. So this was extraction. Rotation now come. So here you have many methods of rotation. So one is none. That's what we have talked about when we were doing factor analysis theoretically, that it is not compulsory to do rotation, because if our items are loading onto factors without rotation, then we may not be requiring rotation at the very first place. So rotation is not a compulsory thing that one should be doing in factor analysis, but it is a helping thing which catalyzes the clear solution. Earlier when we were in confusion whether we should get this into factor 1, factor 2, factor 3, factor 4, Now we are with some clear solution that we should be doing it in F1 or F2. So when you would look at this rotation, if at all you are doing it, then you can click on to Varimax, you can click on to Direct, you can click on to Quatrimax or Equimax or Promax. So, but since we are doing principal component analysis, it depends a lot which extraction method that you are doing, right? In principal component analysis, if you can recall, here in principal component analysis, which I am writing as PCA, we have talked of that our aim is to maximize variance, right? Minimum number of statements that explain maximum of the variance. That's what we do in PCA. We have discussed it. So when we say maximize variance is the ultimate aim of PCA. So have a look at this thing. This is Varimax. So Varimax is nothing but is actually a short form of Vari means variance, max means maximization. So variance maximization. So when PCA talks of maximizing variance, then when we are doing PCA as an extraction method, we should be writing or clicking onto Varimax, which is our rotation method. Now, food for thought that Varimax, which is a rotation method, is actually a orthogonal rotation, right? Orthogonal rotation. So if you can remember, in orthogonal rotation we keep angle of 90 degree between the factors, so this condition is not relaxed. There was another form of rotation that was oblique, and in oblique, if you would look at it, all these Equimax, Promax are oblique rotation. So when you are doing PCA, you go for Varimax, and when you are doing oblique rotation, then you should be doing EFA, which is exploratory factor analysis, which means you would either be going for principal axis for factoring, alpha factoring, maximum likelihood method, or whatnot. So this is how you should actually be selecting that which extraction method to use and which rotation, if at all required, should be adopted. Now one more thing here, which is in fact very important to understand, and that is something that I've discussed on that day also, that if at all you do orthogonal rotation, right? So now this is a method of rotation, this is type of rotation, and this is result of rotation. This is result of rotation. So a result of rotation here in orthogonal would be uncorrelated factors. Uncorrelated factors. In case of this would be correlated factors, right? So this is something that happens. So if at all, and this is say method variance rotation method, I would say rotation method, right? So let's call it as rotation method, and here we are, and here let's call it extraction method. Let's call it extraction method, right? So here when we are doing PCA, we should be doing Varimax, and when we are doing EFA would encompass into it maximum likelihood, right? Principal axis factoring, that is I'm writing as PF, alpha factoring, so you can talk of all the other things, and that would be under EFA. So EFA, you have rotation of oblique, right? And oblique would have Promax is the widely used rotation method when you are doing EFA, and this rotation would be oblique type, and that would give you correlated factors. Alright, now that becomes important for you because many times you just have to understand the need of factor analysis, and the need of factor analysis is, the genesis of factor analysis is that we just want to have a lesser number of statements to be analyzed. You should be keeping it in your mind, and it should be very much crystal clear that we are yet to do analysis. We are not doing analysis here in terms of that it is not going to give us a solution. Now suppose if you were to apply ANOVA, which we have done, that is only that is something which is called as analysis. Analysis is done by techniques like ANOVA, right? So ANOVA, suppose I am going to apply on D1, which is nothing but is say factor 1, right? So I am trying to apply ANOVA on D1 for say occupation, right? Occupation would mean private employee, say government employee, say unemployed, whatever. So now these are the groups that I'm testing. I'm trying to see that D1, which is a factor, which may be any factor, which may be any dimension, but I'm trying to check that under the population which is being studied, these three different categories of employees or those who are unemployed, are they different in their opinions about D1? That is something that is analysis, which means that the factors that we are getting as an output of all these factors, all right, which are output of all these, actually are going to be further analyzed, all right, are going to be subjected to further analysis. So when they are going to be subjected to further analysis, then we have to take care in our mind that the factors that we are getting, are they correlated or uncorrelated? So these two things has to be seen in tandem. Are they correlated or are they uncorrelated? So when we are saying that these two things are to be seen in tandem, because we are going to subject these factors to further analysis, and maybe we are going to apply a technique just for food for thought. Suppose I am going to apply regression analysis, right? If I am going to apply regression analysis, then regression analysis is an assumption that the independent factors into regression analysis should be independent of each other or uncorrelated of each other. So if at all you are going to subject your resultant factors to regression analysis, you want the factors to be uncorrelated. So when you want them to be uncorrelated, then you would go for orthogonal thing. If you have correlated factors and you're subjecting it to factor and regression analysis, then regression analysis, there is a problem called multicollinearity. You will be facing that problem. We are not, the idea here is not to discuss regression analysis, but just to tell you that it is important to know that your factors, which are result of factor analysis, are meant to be subjected to further analysis. So when they are meant to be subjected to further analysis, we need to know that the further tool which we are going to apply, what are its requirements? Does it want factors to be uncorrelated? Does it want factor to be correlated? What? On the basis of that, we do that. And then another way or another method of deciding that which factor method should we be adopting or which rotation method should we be adopting would actually depend on what is our ultimate aim. Are we looking for structure detection or are we looking for just simply reducing the data? So this was just food for thought, just to tell you something little bit more about factor analysis, right? So this is something that we are talking of here. So this PROMAX or this equimax would actually be talking of oblique rotation, but they would give you correlated factors, right? And the reason that they gave correlated and uncorrelated factors were quite obvious, because when we are talking of uncorrelated factors, an angle of 90 degree is maintained between them. So that is something which is called as condition of perpendicularity. When we are talking of uncorrelated factors, we have an acute angle which is less than 90 degree. So when we do not have the condition of perpendicularity, that means that these factors are correlated with each other. And when they are correlated, then they are correlated, and hence cannot be subjected to something which wants things to be uncorrelated. As simple as that. And this was something about rotation thing. So when we have checked on to Varimax, because we have selected principal component analysis as a method of extraction, so we will click on to Varimax. Here we are clicking on to display rotated solution. So when I've rotated the factor solution, I would actually like to see it, right? So that is why I clicked on to rotated solutions, and hence I will click on to continue. Then I will come to scores, I can save the factor scores. So what do we mean by factor scores? Factor scores mean that suppose if I am getting F1, F2, F3, F4 as the resultant factors. So for each respondent that I am having, I would like to know what is score for F1, because you just think about it, that I have these 22 items with me now, right? I have these 22 items with me. So if you would look at, these are the 22 items that I am talking of. So now I have responses of respondents on these 22 items, right? So you are applying factor analysis, you will suppose get these 5 or 4 factors. Now in order to subject them to further analysis, you need to have score for them, right? Score for them. So there are two ways of doing it. One way would be that if your F1 is having statement number 1, 2, 3 and 4 into it, so take a gross mean of these 4, that would become value of F1 is, say, gross mean of 1, 2, 3 and 4, right? So this is what we are talking about. Another way of doing it would be, so let's get little further right down and let's say save factor scores, right? Save factor scores. So by saving the factor scores, we would eventually have, the factor scores for each and every respondent. And when you click onto it, you would come onto regression, Bartlett and Anderson proving. You would click onto regression, right? So you can check it, you cannot check it, depends on you. So since we are doing it for the purpose of understanding, we would check it and we would say continue. So here are the options, the last tab that we were about to discuss, right? So here you are looking at what to do with missing values, exclude cases list-wise, and what do you want to do, the display format. Do you want to look at them in some size which is sorted in a specific order? You say yes, the thing would be easier for you. You say don't, doesn't matter, it is just about display thing. Say continue. And now I am clicking on to OK. So this is the factor output. Now let me talk about these two tests that we have checked while we were at the first tab of factor analysis. Now you look at this first window here, right? Now this talks of KM1 Bartlett's test. So if you can remember in analyze, when we go into data reduction and in factor, right? When we have checked onto this descriptive thing, we have checked this KM1 Bartlett's test of scarcity. That's why we've got this box, right? We have checked onto KM1 Bartlett's test of scarcity, and that was important to check. Let us see why. Now this KMO, which is Kaiser-Meyer-Olkin method of checking sample adequacy, actually checks whether the sample that you are having here or the data that the sample is having, is it adequate or can be subjected to factor analysis. And that is what it is time to check, which is adequacy thing about factor analysis. So a value of KMO less than 0.6 would mean that there is problem with this data and maybe you cannot apply factor analysis onto it. So you set up your benchmark, you want to get it as high as 0.9, nobody stops you, perfectly okay. You have to prove if you are getting this value set at say 0.6, I would take KMO value of 0.6 as an acceptable value. That is to check whether the data is adequate for factor analysis or not. Second, which is Bartlett's test of scarcity. Now this checks the assumption of identity matrix. Now that is something which is important to understand. So now we will be doing Bartlett's test of scarcity. I am writing it as BTS. So there is something which is called as correlation matrix, if you can remember. Now here I have 22 items. I have 1, 2, 3 and it will go on till 22. Again, if I can have this 1, 2, 3 and can go on to 22. So if this would be a correlation matrix, this would always be 1. If you can recall, we have done it also, right? So there you are. And here suppose this is 0.56. Now that would be correlation between statement number 1 and statement number 2. This is 0.56. right? Here also, whatever the value would have been, suppose it is 0.89, now that was correlation between statement number 1 and statement number 3. So this is something which is known as correlation matrix. So when a matrix has correlation at its known diagonal value or at diagonal values, then that matrix is known as correlation matrix. And Barnett's test of sphericity, which is BTS that we are trying to do here, actually checks that this correlation matrix should not be an identity matrix. Alright, so BTS checks that correlation matrix should not be an identity matrix. Now this is important. Now what is identity matrix? What is identity matrix? Identity matrix would be, suppose we have three variables, which is 1, 2 and 3, and here also you take 1, 2 and 3. So here identity matrix would be that only diagonal elements are 1 and rest of the elements are 0. So when this is the case, then we say that it is a diagonal matrix, identity matrix. So why is it an identity matrix? Identity which is 1. You have 1 at diagonal thing, alright? So this actually is 1 only and rest of them are 0, right? So these are 1, rest of them are 0. So on diagonal you will find 1. This is identity matrix. So what does it mean? That 1 to 1 would always be 1, 2 to 2 would always be 1, 3 to 3 would always be 1, but this would be 0. So when BTS checks that the correlation matrix, so when we talk of correlation matrix, now these things which are these ones and zeros are no more any other data figures, but they are correlations between these 2 points that are intersecting here. So when we say 1, that means 1 highly correlates with 1. 0 when we say 2, that means that 1 is not at all correlated with 2. Here 0 means that 1 is not correlated with 3. So an identity matrix would mean that none of the items, here we are talking of 22 items, are correlated with each other, right? None of the items are correlated with each other. That would mean that there is no correlation in between. And how does factor analysis work? It works that the items which are highly correlated with each other are clubbed together to form one factor. When they are not correlated with each other, you cannot apply factor analysis, and hence it checks whether it is a correlation, whether this correlation matrix is an identity matrix or not. If it is an identity matrix, we cannot apply factor analysis, because then we say that there is no correlation between the items, and hence they cannot be clubbed together, because like statements would be clubbed together, unlike statements would not be clubbed together. They would become different factors, right? So if we can look at this output thing here, a value of less than 0.05 would mean that it is not an identity matrix, which means there is some correlation, right? So we can always have correlation thing. If you can remember, we can go on to scale, we can do reliability analysis, and then we can drag these 22 items here, all right? So we have done it when we were doing scale things, and you can go to statistics, and then you can say I want inter-item correlations thing. I'd say continue, press OK, you get this thing, right? Now there is this correlation matrix too. I can copy it and I can get it back to say Excel sheet. So this is correlation matrix, so I can paste it here, right? So there you are. So this is 0.55. So between this statement and this statement, correlation is this. So obviously this is not an identity matrix. Had it been an identity matrix, these were ones, but all these would have been 0, right? So since these are non-zero correlation values, that means it is not an identity matrix, and that is why that here you are getting KMO value as 0, 0, 0. All right. So if it is less than 0.05, that means that it is not an identity matrix. So these are commonalities. So I would not be discussing it because it relates more to EFA rather than PCA, which is principal component analysis. Now this is an important table for us to understand, right? Now these components are what? Now see, we've applied PCA as a method of extraction, which is principal component analysis. So PCA as an extraction method would give you components which are nothing but factors, our dimensions, or whatever name you may like to give them. So these are components, and now it will tell you that how many components to extract. So this is the variance that is explained. So this is first factor. You can have, you can always have the number of factors which are equal to the number of items that you are having into your questionnaire. But that is not the purpose. The purpose is to have the minimum number of components, minimum number of dimensions that explains maximum the variance. So you have first factor here, first component here, which can explain 54.104 of the variance. And why so? Look at the eigenvalue. Now this column is for initial eigenvalues. 11.903. 11.903 obviously is much more than 1. And we have set the condition, if you can remember, analyze, data reduction, factor, and we have kept extraction condition as eigenvalue over 1. Now it is not only over 1, it is over 10 also. So that is why you would see that this factor or this component is taken ahead into analysis, and we have extracted sum of square loadings. Alright. Second factor, it has an eigenvalue of 1.317. So this much is the amount of variance that it explains out of the total 100% variance. So these two factors, the dimensions that we have got out of it, explains almost 60% of the variance, and hence this is also taken ahead 60%. Then this is third factor, which has an eigenvalue of 1.1. Variance explained is 5.069, and the cumulative variance that we have is 65%, and that is why it is taken ahead. Now fourth factor, it has an eigenvalue of less than 1, and hence it is not taken ahead. So the further values are not calculated because we have set eigenvalue 1 as our criteria of extracting factors, right? So these three factor solution that we have come across actually explain 65% of the variance, which means 65% of the change that we were talking about, 65% of the information that we were talking about is actually explained by this model of factor analysis, right? Now if you can hide the right part of it, and if you would just look at these two columns, then these are initial eigenvalues, these are extraction sum of square loadings, and that is done. All right, this was the case when you would not have done rotation thing, right? Rotation thing. Now let's get down. So we look at this rotation thing later on. So I am just getting down now. Now this is my scree plot. So scree plot would help me in finding out how many factors should I extract out of the solution. So the drop that you see, the last and the major drop that you see in this scree plot would actually tell you the number of factors that should be extracted out of it. Now see, there is confusion here because eigenvalue thing says that 3-factor solution is coming out of this factor analysis, whereas scree plot tells you that this is only 2-factor solution, because this is the last drop, that sudden drop that has taken place. After that we are coming up to 2 and 3. So let's take 2 factors. So there are only 2 factors that can be easily extracted out of it. All right, so better it is that we go with 3-factor solution, because if at all I'm going for 2-factor solution, look at the variance that I'm having, it is only 60%. All right, so the information loss is almost 40%, but if I make factor number 3, then 65% it comes on to. And if I even include the third, fourth factor also, despite it having an eigenvalue less than 1, then it would be explaining 69% of the information. But if I take all the 22 components that I'm talking of, I will have 100% variance. So the lesser number of components that you draw out of it, less amount of information that you would be extracting out of it. So that is precisely when we were discussing that when you are having lesser number of things with you, instead of all the things with you, you are bound to lose some information, and information here is nothing but the name given to information is variance, right? So now coming down, this is component matrix. Component matrix is, this is simply result of PCA, which is principal component analysis. Now these are factor loadings. All right, these are factor loadings. Now this is precisely that what I was telling you. So if I can copy it and take it up in Excel, now let's paste it up. So Now this is factor number 1, this is factor number 2, this is factor number 3, and these are the loadings. So which is the maximum loading? So there you are having maximum loading, and let's mark it green. So this first statement goes to factor number 1, right? This is as good as saying, when we were trying to understand this thing, that now if this is my f1, here I have 3 factors, now this is f1, so this is first statement that I am talking about, this is nearest to f1, right? Because this has maximum factor loading for first factor, this is here. So it is 0.02 for second factor, which means if I talk of f2 here, now f2 eventually for statement number 1 is actually far, look at the farness of factor number 2, and that is why this thing is only 0.02. Now this is 0.53, so that is somewhere close to it. So if I can draw another factor out of it, say this is the factor number 3, so it says that the distance of it from this factor is also somewhere equal to what is its distance from f1. So now the challenge here is, because if you would look at the difference between this thing and this thing, then you would say that it is only 0.11, which is not for that matter a big difference. So now you are confused whether you should take one statement into factor number 1 or factor number 3. That is the problem that we were talking about. Now look at the second thing. Looking at the face value of it, it is clear that it should be going in factor number 1, because this is maximum factor loading for it. Looking at third, it also goes in factor number 1. Now looking at fourth thing, the fourth statement goes in factor number 2. So that way we will keep doing, and we will keep identifying that how many statements would form part of factor number 1, f1, right? So f1 currently has 1, 2 and 3, right? So fourth is also coming into 1, so fifth is also coming into 1, maximum thing, right? So that way 7, 8, 9, 10, 11, 12 and till this point, and if I go down also, then I would say that I have lot many things into factor number 1 also. Now that solution does not seem to be stable one, and that is the problem, that everything is loading into factor number and 1 only. So why do we have factor number 2 and 3, whereas only one statement going for factor number and 2, and there is no statement going into factor number 3? Have a look at it. So this is an unstable solution, and that is the confusion that is created to us by simple component matrix, and that is why we need a rotation matrix, right? So let us have a look at rotation matrix now. So now instead of component matrix, which is here, we would go into rotated component matrix. Now it is clear that first statement is going into, now let's write it down here. So now here I am trying to place it. Now this is rotated component thing. Now first thing is going into factor number 1, right? The second thing is going into factor number 2, sorry, second thing is going into factor number 2. The fourth thing is going into factor number 3, right? And this thing is going into factor number 4. So you see the difference now. When this was confusing, 0.53 is not very far away from 6.5. So one was confused whether you should take it in 1 or 3. It is very clear here, because 0.76 is too far away from 0.36 or 0.03. So now we are very clear. So that is the beauty of rotated things. When we rotate the factors, we can easily identify which statement would make part of which factor. So here you will have something like this, which actually says that some of the things would go in one factor, rest of the things would go in another factor, and that way you keep on doing the things. So this thing is going into factor number 2. So now you see that statements are divided into all 3 factors, right? Some are going more in factor number 1, some are going more in factor number 2, some of them are going in factor number 3. So that way, this is the solution that we are drawing out of it. So each factor has at least 3 statements. Now this has obviously more than 3, but this has 3 statements, and this factor number 3 also has 3 statements under it. Not like this solution when we do not have any statement in factor number 3. Right? So this was an unstable solution. This solution at least seems to be little bit stable. So this is how now we know that it is only because of rotated thing that we have realized, that from 5 to 17 and 21, right, and 21 and 22, so 5 to 17 and 21 22 come in factor number 1. So when we talk of factor number 2, now we know it is 1 2 and 19 statement, and when we talk of factor number 3, we will talk of statement number 4 and statement number 18 and statement number 20. So this is how we have three factors generated out of this. Now 22 statements would be represented by these three factors, but if we can go back, how much information we are losing in the process is at least 35%. So when you would look at this rotated thing, because we know now that the previous thing which was not rotated was actually not giving us a stable solution, we would rather look at the rotated thing. Now look at the rotation. So rotation, when second factor was only having an eigenvalue of 1.31, now it has an eigenvalue of 3, so it has a more variance being explained. And that is why the items, when they were in unrotated things, suppose that if, now have a look at this Excel sheet, when this thing was, the first statement was in factor number 1, now it is shifted to factor number 2. Because when you have this point here, right, and when you have this point here, earlier if you rotate this thing like this, now earlier when it was in F2, maybe it now can come into this factor. So the statements keep on rotating with the factors, and they keep on loading onto factors, and that is by looking at this output sheet we realize that how much information have we got out of this solution. So instead of 22 statements you were analyzing, now you only analyze 3 statements. This is rotated things for you, and it is rotation thing that has made our life easier for us, right? This is a rotated thing. So now that was the scale reliability thing that we measured, so that is not part of factor analysis. So factor analysis is finished till this point. So when we were talking convergence, now see rotation converged in 11 iterations, so 11 times it has to rotate and it converged. So this is a factor to you. Now the last thing which is left into factor analysis is, if I can go here, now you look at statement number 4, 18 and 20, which are part of factor number 3. So now look at this. Here we were talking of 4, 18 and 20. 4, 18 and 20. So fourth statement, you read it up. Materials associated with the services are visually appealing. And then 18, our hospitals gives individual attention, and 20 are staff who gives patient personal attention. Now you have to study these three things. Now the very fact that they have come into one factor, so that means that they are related to each other, they are close to each other. Now the second job of ours would be to give this factor a name by looking at the similar kind of statements that are being clubbed into it. Now this is to say that when you have all the people who are doing science stream, let's call them BSc thing, let's call them engineers. So the same way, these three statements which are being clubbed into one factor, and now it was called as F3, now let's give it a name. Alright, so that way we give it a name. Now the question arises, what is the value of F3? So if I can go back to Excel, now data view, if you can remember, now first let me show this to you. Now look at this thing, factor 1, factor 2 and factor 3, right? 1, 2 and 3, they have their scores. So respondent number 1 has a score of 0.11081 for factor number 1. Respondent number 2, so same way I have this factor scores for all the respondents that I am having. They were 132 number, and that was because when I've gone on to this and gone into factor, if you can remember, scores, they were saved as variables, and that is why you're looking them here. So if you would like to look them in variable thing, now this is variable view, you can get down the 3 variables have been created. Now this is your factor 1, factor 2, factor 3, and you can give it a name. So whatever name you give to factor number 1, you can type it here. Suppose I have given it like individual attention. That becomes one dimension to check of service quality. So if I'm given individual attention, I would say that service quality is better. So that way you can give the names to factor. Now the last thing, if if you would look at this Excel sheet, we were talking about it here. If at all I am not giving or clicking on to save as variable thing, what will be the values of f1, f2 and f3, right? What will be the values of f1, f2 and f3? So that thing, when I know that factor number 3 has 4, 18 and 20 items into it, so I can make a gross mean of it. If you can remember, we have typed gross mean, right? So gross mean, how to do it? So you go here and you go to transform and then you compute and you say here factor 1, right? And you can type the label of this factor number 1, that was individual attention, right? And you say continue. And here, since you have to take gross mean, so from this function group you can select a statistical function. So this is statistical function, and that you can select mean, because you have to take gross mean and you get it up. So there you are mean. So mean was of statement number 4, drag it down, and question number 18, and there you are having question number 18, drag it down, and then you have last thing was question number 20. So in 20 you will drag it down, and then you will say okay. Look at here, factor 1 has come, and this is the score for first respondent, this is score for second respondent, this is for third respondent. So every respondent has a score for factor 1, right? So that way you can actually come to have all the factors that you are having. Now what will you do? You would not look at the 22 statements that you have measured, which are these till here 21 and 22, but rather you would look at these factors now and you would take them in further analysis rather than taking them into analysis, right? So this is how we tend to do factor analysis, and this is how we reduce the data from a larger number to a smaller number. And now I have only 3 things to take ahead and I will analyze them. So it has made my work a lot easier, right? So I hope it made sense, right? So any questions from you, Manjula and Rajat?